It is difficult to classify as either a comet, an asteroid, or something artificial. But it might be important to reach such a classification, as 6 new objects have been detected in our solar system that share Oumuamua's most bewildering trait: its ability to accelerate with no clear explanation for where such acceleration is coming from. Welcome to Infinity Beyond. Today, we're diving into the enigma of Oumuamua and 6 newly discovered, fittingly named dark comets, and the strange theories that scientists have proposed in recent years to explain their baffling behavior. Let's start with a quick recap. Oumuamua is the first recognized interstellar object to arrive in our solar system. It did so on October 19, 2017, and was spotted by the Haleakala Observatory in Hawaii. Scientists quickly noticed there was something strange about it. It was small, perhaps between 100 and 1,000 meters long, and believed to have an unusual shape, possibly a cigar or a flat disk. Its trajectory and speed made it clear that it wasn't from our solar system and would eventually leave it. The object was named Oumuamua, Hawaiian for scout or first distant messenger, since it was the first confirmed interstellar visitor, though certainly not the first to pass through undetected. Scientists were eager to study it and see how it compared to objects found locally in our solar system. But as they studied it, things only got weirder. While Oumuamua was initially classified as a comet, it lacked a coma or cometary tail, making it appear more like an asteroid. This was puzzling, especially when the object was seen accelerating away from the Sun, a trait more typical of a comet venting gas, but one not displaying the usual signs of doing so. The rate of acceleration was small, only about 17 millimeters per second, but significant enough to cause a stir in the scientific community. According to classical physics, an object cannot accelerate without being pushed by some force. Scientists scrambled for explanations. Solar radiation pressure? Maybe, but not quite enough. The acceleration was too large to be explained solely by solar winds if the object were just an ordinary asteroid. Theories about its shape came into play. Since it was tumbling and the brightness of its light curve varied, it suggested an irregular shape, a cigar or flat disk, rather than a sphere. Still, that didn't solve the mystery. If it were a comet, it should have emitted visible gas or dust. But astronomers didn't see any. That's when more exotic theories emerged. The first came from Harvard professor Avi Loeb. In a bold 2018 paper, he proposed that Oumuamua was actually alien technology, a light sail, perhaps just 0.3 to 0.9 millimeters thick and up to 1,000 meters long, created by intelligent life to travel between stars. He argued that only something so thin could accelerate the way Oumuamua did using solar radiation. Naturally, this created quite a stir. Not everyone agreed. Enter Daryl Seligman, a postdoctoral researcher at Cornell University. In 2020, he co-authored a paper suggesting an alternative. Maybe Oumuamua was outgassing hydrogen, an invisible gas that would not have been detected by the telescopes used. He theorized that the object was a hydrogen iceberg, made largely of frozen hydrogen, which sublimated near the Sun and caused the acceleration. But Loeb fired back. He published a paper showing that hydrogen icebergs couldn't survive the journey through interstellar space. The radiation from even the nearest stars would cause them to evaporate long before reaching us. Still convinced that an alien explanation was most likely, Loeb's arguments were strong enough to push Seligman to refine his theory. He eventually dropped the pure hydrogen iceberg idea, but he didn't abandon the notion entirely. In 2023, Seligman found renewed interest when working with Jennifer Bergner, an assistant professor at the University of California. She pointed to lab experiments where water ice, under extremely cold conditions and hit with cosmic radiation, released trapped hydrogen gas. This offered a new possibility. Perhaps Oumuamua wasn't a hydrogen iceberg at all, but a regular ice body that had undergone radiation processing during its long voyage through interstellar space. That hydrogen, now trapped inside, could be slowly released when the object neared the sun, causing the gentle push observed without the need for visible outgassing. Was that the answer? Or was Loeb's alien sail hypothesis still on the table? As more dark comets are discovered, objects that accelerate mysteriously like Oumuamua, the debate only deepens. Are they icy wanderers shaped by cosmic radiation, or relics of advanced extraterrestrial civilizations? For now, the mystery of Oumuamua remains unresolved. But one thing is clear. It opened a new window into interstellar science, and perhaps into something far more profound. What if water ice in space, exposed to cosmic radiation, could trap hydrogen, only to release it later when warmed by the sun? That's exactly the scenario explored by scientists Jennifer Bergner and Daryl Seligman. Their lab-based reasoning suggested that as frozen structures reorganize under heat, trapped hydrogen could escape, pushing the object subtly without any visible outgassing. This process wouldn't create a dusty tail like typical comets. Instead, the object would silently release gas, altering its trajectory in ways nearly impossible to see. The result? A new kind of celestial body, what they called a dark comet. These invisible comets wouldn't behave like regular ones. They wouldn't emit the usual tails or plumes, but would still accelerate quietly, stealthily like Oumuamua did. The concept was compelling enough to challenge mainstream assumptions. However, Avi Loeb wasn't convinced. He co-authored more papers accusing Seligman of flawed mathematics and continued to advocate for his alien sail hypothesis. Yet Seligman wasn't deterred. If Oumuamua could be a dark comet, he wondered, what if there were others? He and his team scoured databases of near-Earth objects, looking for similar behaviors. These weren't interstellar visitors like Oumuamua, but solar system natives. Still, could some be dark comets too? To their surprise, yes. They identified 6 known objects that exhibited unexplained acceleration. These weren't large or flashy. Some were as small as 3 meters across. They looked like harmless asteroids, quietly orbiting Earth. But they moved, oddly. Their acceleration couldn't be explained by gravity, solar wind, or radiation pressure. And unlike comets, they had no visible outgassing. These were objects hiding in plain sight. Among these mysterious 6 was a particularly interesting case. 1998 KY-26. It spins rapidly, once every 10 minutes, and is scheduled for a flyby mission in 2031 by Japan's Hayabusa 2 spacecraft. Hayabusa 2, originally launched in 2014 and having completed its primary mission, has been given a new goal: to study additional asteroids. And KY-26 is one of them. It's small, rich in water, and exhibits unexplained behavior. Scientists hope this mission will provide crucial insights, not just into KY-26, but also the broader dark comet phenomenon. Could KY-26 be the key to solving the Oumuamua mystery? If KY-26 is found to accelerate due to invisible hydrogen outgassing, it would lend strong support to Seligman's theory. On the other hand, if something truly unnatural were discovered, a hatch, a mechanism, an intentional design, it might finally vindicate Loeb's alien hypothesis. Realistically, KY-26 is likely not an alien spacecraft. We have high-resolution imagery, and it appears quite natural. But science thrives on surprises. Even if neither Seligman nor Loeb is entirely right, the study of these objects pushes us into new territory. This is what makes science so thrilling. Each new anomaly challenges our understanding. The more we observe the cosmos, the more we realize how much we don't know. And sometimes these anomalies rewrite the textbooks. Perhaps future interstellar visitors will offer more definitive clues. Or perhaps we'll discover even stranger objects, forcing us to invent new physics to explain them. Either way, the scientific journey is far from over. Now, let's shift perspective. Beyond dark comets and strange accelerations lies the age-old question: are we alone? For decades, humanity has poured vast resources into answering that question. We've built telescopes, launched satellites, sent robotic rovers to distant worlds. We've listened to the stars for alien signals and broadcast messages into the void. Why? Because it seems statistically improbable that life emerged only once, on a pale blue dot orbiting an average star. The discovery of even a microbe on another world would change everything. It would confirm that life is a cosmic phenomenon, not just an earthly accident. But what if we've already been visited? Many claim aliens are already here, watching silently or even walking among us. Videos of strange lights, government whistleblowers, and conspiracies flood the internet. But most of these lack solid evidence. Hoaxes, lens flares, and misidentified aircraft account for the majority of UFO sightings. In fact, some argue that the U.S. government itself may have encouraged UFO speculation, possibly to hide secret military technology, like stealth bombers or advanced drones. So how do we separate science from speculation? Science demands evidence. We can't leap to alien conclusions just because we lack explanations. Still, that doesn't mean we stop searching. Curiosity drives us, and strange cases like Oumuamua and KY-26 fuel that fire. In upcoming episodes, we'll explore how the U.S. Navy and NASA have responded to unidentified aerial phenomena, and whether new technology is finally bringing us closer to the truth. In 2022, multiple U.S. government agencies, including the Pentagon, began taking UFO sightings seriously. Why? Because they had no choice. There's now a growing body of scientific evidence, verified radar contacts, infrared video, and multiple highly trained military pilot eyewitness accounts. These aren't blurry amateur clips or lone wolf claims. They're solid, repeatable, and cross-verified by modern technology. Let's dive into the encounter that changed everything: the 2004 USS Nimitz Tic Tac incident. It began with a training mission off the coast of Southern California. The USS Princeton, a U.S. Navy ship equipped with advanced radar systems, detected strange aircraft maneuvering in ways that defied conventional flight physics. Objects were dropping from 80,000 feet to near sea level in under a second, then vanishing or reappearing miles away. After days of these readings, the Princeton called for visual confirmation. Two FA-18F Super Hornet fighter jets were scrambled, each carrying 2 trained pilots and equipped with forward-looking infrared (FLIR) targeting systems. When they arrived at the coordinates, they spotted it: a white, oval object, about the size of a commercial plane, but smooth, wingless, and silent. It hovered just above a patch of churning water. No rotors, no exhaust, no obvious propulsion. The object performed impossible maneuvers, zigzagging in mid-air, then suddenly stopping, pivoting, and accelerating faster than any known aircraft. One pilot later described it as moving like a ping-pong ball inside a glass jar. And just like that, it was gone. It reappeared 60 kilometers away less than a minute later, tracked by radar. The pilots were stunned. These were not hallucinations. The onboard sensors confirmed everything. This was not just a visual encounter. It was multi-sensor, multi-pilot, multi-platform. In any scientific framework, that's strong evidence, strong enough to demand serious attention. And yet, for decades prior, the U.S. government had officially ignored or downplayed UFO reports. Programs like Project Blue Book, which analyzed thousands of sightings from 1947 to 1969, concluded that most were misidentified aircraft or natural phenomena. That conclusion shaped public perception for generations. UFO witnesses were often dismissed or mocked. But the Tic Tac incident changed the game. It matched all the criteria scientists use to validate extraordinary claims. Multiple trained observers, technological sensor data, radar, infrared, physical characteristics defying conventional engineering. Repeatability. The objects were tracked over multiple days. Following the release of the Tic Tac footage and other verified Navy videos, the Pentagon was forced to admit that unidentified aerial phenomena, UAPs, are real and worthy of scientific inquiry. This led to the creation of new government task forces and open congressional hearings. Pilots and intelligence officials were invited to testify. For the first time in modern history, the U.S. government acknowledged that it does not know what these objects are. Are they secret military tech, foreign surveillance drones, or something beyond? We don't have the full answers yet. But what we do have is enough to shift the global conversation. The stigma is eroding, science is catching up, and Infinity Beyond will be here to guide you through it, one unexplained mystery at a time. By 2022, the U.S. Navy and Air Force were reporting UFO sightings so frequently, some pilots claimed they were happening almost daily. Many were afraid to speak up, fearful of being ridiculed. But things began to change. The Navy started issuing cards to pilots, outlining procedures for reporting unidentified sightings. Between 2004 and 2021, there were 144 official reports. In 80 of them, the objects were detected by multiple sensors, and 11 incidents involved near collisions with jets. Only one case was ever positively identified. Then came a turning point. Between 2021 and 2022, pilots were encouraged to speak up, and the numbers surged. 247 new reports and 119 older incidents were added. That brings the total to 510 cases, nearly one every other day. These weren't just balloons or camera glitches. Some objects hovered in place, defying the wind. Others accelerated like no known aircraft. Some moved underwater as easily as in the air. Some resembled drones, but stayed airborne far longer than any known model. One infamous triangular object, thought to be a drone, was later linked to camera distortion caused by night vision goggles. Still, many of these sightings couldn't be explained away. That's why the U.S. military rebranded them as UAPs, Unidentified Aerial Phenomena. And more recently, UAPs have become UAPs, Unidentified Anomalous Phenomena, to include those that move underwater or defy physics altogether. In May 2021, officials briefed Congress, and for the first time, the government acknowledged, we don't know what these things are. Now, they're asking the public and scientists for help. NASA has even joined the investigation. Administrator Bill Nelson said, "We hope it's not an adversary here on Earth that has that kind of technology, but it's something. We're constantly asking, who is out there? Who are we? How did we become who we are?" He adds that NASA scientists are working with the UAPS task force to rule out known natural phenomena, and so far, many of these events remain unexplained. Could these be secret technologies from rival nations? Possibly, but even the U.S. military doubts that. If these were human-built, someone would know, and if they're not ours, and not natural, what's left? That question leads us into the Fermi paradox. There are over 100 billion planets in the Milky Way. At least 30 million are estimated to lie in the Goldilocks zone, not too hot, not too cold, where life could thrive. If even 1% of those developed intelligent life, and if even 1% of that reached spacefaring status, there should be thousands, even millions of alien civilizations. We should be seeing them everywhere. But where are they? That's the essence of the Fermi paradox, posed by physicist Enrico Fermi. If they're out there, why haven't we seen them? Perhaps we have, and didn't recognize it. Or worse, we ignored it. Could UAPs be the quiet evidence of an ancient galactic civilization monitoring us? Or are we witnessing new breakthroughs in human technology, cloaked beneath secrecy? We still don't know, but one thing is clear. Something real is flying through our skies, and infinity beyond will be watching closely. Since 2004, U.S. Navy and Air Force pilots have reported seeing unidentified objects in the sky. But in recent years, those sightings have surged and become impossible to ignore. Between 2004 and 2021, there were 144 UAP reports. In 80 of those, the object was detected by multiple sensors. 11 came close to military jets, but only one was explained. In 2022 alone, that number jumped. 247 new reports, plus 119 older ones added. The total? 510 documented encounters. Some of these objects hovered motionless against the wind. Others moved between air and water seamlessly. Some looked like drones, but stayed in the air longer than any known model. Others flew in formation, with unnatural acceleration. In response, the military dropped the term UFO, too loaded, too sci-fi. The new term, UAP, unidentified aerial phenomena, and later expanded to unidentified anomalous phenomena to include underwater and space anomalies. And that wasn't the only shift. The Navy began training pilots to report sightings instead of staying silent. They even issued cards with protocols in case a UAP was encountered in flight. In 2021, U.S. intelligence officials gave a public report to Congress. They admitted they had no explanation for most of the objects. They didn't believe they were secret U.S. tech, and they had no evidence they belonged to foreign adversaries. The mystery deepened. Now, even NASA is involved. Administrator Bill Nelson confirmed the agency is helping the UAP task force rule out natural explanations. His words were chilling. We hope it's not an adversary on Earth that has this kind of technology, but it's something. And so, we keep asking, who is out there? How did we get here? Are we alone? It's a monumental shift in attitude. For decades, sightings were dismissed. Pilots were afraid to speak. The stigma was strong. But that's changing. Now, the U.S. government is calling for open investigation, citizen science, and transparency, a move that could redefine the search for extraterrestrial intelligence. Which brings us to the Fermi paradox. In the Milky Way alone, scientists estimate 100 billion planets. Around 30 million are in the Goldilocks zone, not too hot, not too cold, where life could potentially arise. If even 1% of those worlds developed intelligent life, and if even 1% of those civilizations became spacefaring, we should be seeing evidence of thousands, maybe millions of alien races. So, where is everyone? That's the core of the paradox posed by Nobel Prize-winning physicist Enrico Fermi. If the universe is teeming with life, why haven't we encountered it? Maybe we have. Maybe the 510 UAPs logged by the U.S. Navy are whispers of a cosmic presence. Or maybe they're natural, strange, but explainable. Or maybe they're our own secret technologies. We still don't know. But here's what we do know. Something is flying in our skies. It's been recorded. It's been seen. And for the first time in history, the most powerful military in the world is admitting we don't know what it is. This could be the beginning of something extraordinary, or the ultimate reminder of how little we understand. At Infinity Beyond, we'll keep following the clues and bringing you closer to the truth, one revelation at a time. What if alien civilizations exist, but we're just not able to see or hear them yet? In this segment, we explore the idea that even if life is widespread in the universe, natural barriers may prevent us from detecting it. The first possibility is simple. Maybe there's no one else out there. Life may be so rare, or the path to intelligence so unlikely that Earth is the first or only planet to reach this stage. But what if that's not true? Then we must face the real challenges of space and time. Communication with another civilization requires either we contact them or they contact us. We could send spacecraft or robotic probes. But here's the problem. At current speeds, space travel takes far too long. The Voyager 2 probe took 49 years to leave the heliosphere, and it's still not even halfway to the nearest star, Proxima Centauri, which is 4.2 light-years away. At Voyager speed, it would take over 80,000 years to reach it. So we turn to signals, radio or light. These move at light speed, 300,000 km/s. But even that speed presents a challenge. We've only been sending radio signals into space since the late 19th century. That means the farthest any message from us has reached is just over 120 light-years. That's a tiny bubble in a galaxy 100,000 light-years wide. Let's imagine an alien race 500 light-years away. Even if they heard us instantly and replied the next day, we wouldn't receive that reply for 1,000 years. Unless they contacted us first, we're not likely to hear anything for centuries. Now flip it. What if they're trying to reach us? We have the tools to detect distant signals, including the James Webb Space Telescope, which can see galaxies over 13 billion light-years away. If alien civilizations started broadcasting billions of years ago, their signals could be reaching us now. But there's a catch. We may not recognize the signal, or it may be too faint, or the signal may not be aimed at us. We may be listening at the wrong frequency, or at the wrong time. This brings us to a real event that fuels this debate: the WOW signal. In 1961, Ohio State University built a massive telescope called Big Ear. Its goal: search the skies for radio signals that couldn't be explained naturally. On August 15, 1977, it picked up a signal unlike anything ever recorded. It was 30 times stronger than background noise, narrow band, consistent, and it lasted 72 seconds. Astronomer Jerry Amon circled the data and wrote, "Wow," hence the name. But the signal was never repeated. That's the problem. Without repetition, science can't confirm it. Maybe it was a brief alien ping. Maybe it was a cosmic coincidence. Maybe it was interference. But if it was intelligent, it's now a whisper lost in the void. In conclusion, communication with alien life may be possible, but it's limited by the speed of light, the vast distances of space, the timing of civilizations being active at the same moment, the technology used to transmit and receive signals, the methods of communication we don't yet understand. Maybe we're listening, but no one's transmitting. Maybe someone is transmitting, but we're not listening right. Or maybe we're still too early in the cosmic game. One day, we may discover that the galaxy has been full of life all along, but like travelers in the night, we just passed each other in silence. Until then, the search continues. In 1977, a powerful and unexplained signal was captured by the Big Ear radio telescope at Ohio State University. It lasted 72 seconds, was 30 times stronger than background noise, and had all the hallmarks of a deliberate transmission. Astronomer Jerry Amon circled the printout and wrote a single word: "Wow." The WOW signal had a smooth, uniform strength pattern, like a sweeping beam from a lighthouse. It rose in intensity, peaked, and faded out. But when Big Ear turned back to that section of sky, it was gone. And despite decades of follow-up, we've never heard it again. Why? One reason may lie in how Big Ear was built. It couldn't track targets freely. Instead, it relied on Earth's rotation to scan the sky. It could only Listen to a specific region for a few minutes at a time. That means the wow signal might have continued broadcasting, but Big Ear wasn't listening anymore. It's like hearing a single note from a symphony and missing the entire performance. This reveals a deeper problem in how we search for alien life. Organizations like SETI focus on wide sweeps of the sky, hoping for a lucky hit. They don't have the time or funding to point telescopes at one patch of sky for weeks, months, or years. It's like fishing. Instead of leaving the line in one spot, they cast again and again, hoping for something to bite. But aliens aren't fish. They don't respond to lures. If a signal only broadcasts once a year, or once every 100 years, we'd need constant monitoring to catch it. Over the years, many signals like the wow signal have been picked up. Odd bursts, pulses, or structured noise that can't be easily explained. But without dedicated follow-up, they remain mysteries. So what was the wow signal? A machine glitch? Possible, but no known faults were detected. A natural phenomenon? Maybe, but nothing has matched it since. A message? That's the big question. If it was a signal from intelligent life, we may have just missed the reply, or the second broadcast. Here's another issue. We can't be everywhere all the time. The sky is vast, resources are limited, and our methods are still primitive. Maybe we're scanning the sky with outdated assumptions. Maybe alien civilizations broadcast in ways we haven't imagined, using laser pulses, neutrinos, or quantum entanglement. Or maybe we're too impatient. Science demands repetition and patience. But what if the universe doesn't repeat itself on our schedule? In the end, the wow signal remains the most promising candidate for an alien broadcast ever recorded. And the fact that it never happened again, that might be the most mysterious part. At Infinity Beyond, we believe the truth is still out there. And one day, we may look back at that 72-second blip in 1977 and realize it was the first time we were noticed. We've asked why we haven't heard from aliens. But what if we already have? In this episode, we explore some of the most promising alien signal candidates ever recorded. These signals, while not fully confirmed, remain fascinating in their characteristics and raise important questions about whether we're already hearing whispers from the stars. Let's start with BLC-1. In 2019, scientists using the Parkes-Murray-Young radio telescope in Australia detected a narrow-band signal during observations of Proxima Centauri, the closest star system to our own. The signal lasted for several hours. It showed drift, a shift in frequency consistent with motion, which implies it wasn't local interference. Most importantly, it was a thin, narrow-band transmission, a trait typical of artificial signals. Nature doesn't make radio waves that precise. Technology does. Could this have been it? A real alien signal? Unfortunately, follow-up observations couldn't detect BLC-1 again, and researchers eventually found similar signal patterns on other days, even when the telescope was pointed elsewhere. Conclusion? Possibly interference, but not definitively. That ambiguity keeps BLC-1 in the running, right next to the wow signal, as one of the strongest candidates for extraterrestrial communication. Next up, SHGB02+11A. A mouthful, yes, but don't let the name fool you. This signal might be even more curious. It was detected in 2003 using the Arecibo telescope as part of the Email Protected Initiative, a distributed computing program involving over 5 million personal computers scanning the skies. Here's why SHG is special. It broadcast at 1420 MHz, the natural emission frequency of hydrogen, one of the most abundant elements in the universe. Many scientists believe this frequency would be used by alien civilizations as a cosmic calling card. It was detected 3 times. It originated from a region of space with no nearby stars, up to 1,000 light-years away. It showed signal drift, but with patterns that seemed off. Unfortunately, SHG was too weak to confirm whether it was technological in origin. It didn't seem to be interference, but it also wasn't strong enough to rule out natural causes. This is the recurring theme in the search for alien life. We get close. We detect something strange, something unique, something that feels engineered, but we can't say for sure. Why? Because we don't follow up long enough, or we lack confirmation, or we're limited by equipment, budgets, and assumptions. Let's not forget, aliens aren't human. If they exist, their logic, language, and even their idea of communication may be totally alien to us. A signal we dismiss as noise might be a greeting. A frequency we ignore might be sacred. A blink we miss might have been our first contact. And so, we wait. We listen. We record. And sometimes, first we wonder, have we already heard them and just not known it? At Infinity Beyond, we believe that the evidence is mounting. Maybe aliens are not light years away in the future. Maybe they're already whispering from the stars. If a signal came from aliens, how would we even know? In the search for extraterrestrial life, the process used by scientists is grounded in a principle famously quoted by Sherlock Holmes. When you have eliminated the impossible, whatever remains, however improbable, must be the truth. SETI researchers apply this logic rigorously. When a strange signal appears, like BLC1 or SHGB02+14A, they start ruling things out. Known satellites, natural cosmic sources, Earth-based interference. Sometimes nothing fits, which brings us to a whole new category of phenomena: fast radio bursts, or FRBs. First detected in 2007, FRBs are ultra-short, lasting mere milliseconds, but incredibly powerful bursts of radio waves coming from deep space. Hundreds have now been observed. Most are from galaxies far away, but one in 2020 was recorded inside the Milky Way. That got scientists' attention. Where do they come from? Theories include magnetars, highly magnetized neutron stars, collapsing black holes, exotic cosmic events, and yes, advanced alien technology. Why the alien theory? Because FRBs are so brief, so precise, and sometimes repeating, all traits that could align with artificial signals. The CHIME telescope in Canada was built specifically to detect FRBs. Instead of pointing at one spot, CHIME scans a wide swath of the sky continuously. It's helped discover many FRBs, some repeating, some not. And one, they found, might even follow a predictable pattern. That brings us to the most tantalizing possibility: an intelligent signal. Maybe a civilization doesn't want to be seen all the time, but pings the galaxy once every X number of days, on purpose. Maybe we're just now noticing. Of course, natural explanations haven't been ruled out, but not knowing for sure is part of what makes science and the universe so compelling. But this isn't just a cosmic mystery. Let's bring it closer to home. Earth itself has mysteries we don't fully understand, like ball lightning. Ball lightning is a glowing orb of electrical energy that allegedly floats through the air, sometimes through walls or inside airplanes. It's been reported for centuries, even by scientists, but remains extremely rare and hard to capture. It's so strange, some thought it was just a myth, but researchers today are taking it seriously. Just like with FRBs, scientists are now using advanced instruments to study and even try to recreate ball lightning in the lab. Why does this matter? Because it shows us that strange doesn't mean fake. Sometimes the universe is just stranger than we're ready for. Whether it's a mysterious burst from a distant galaxy or a glowing orb in a thunderstorm, these are clues. Clues that we may be close to discovering something new, or someone new. And at Infinity Beyond, we believe it's only a matter of time. What if our solar system holds a massive secret? An undiscovered planet 5 times the size of Earth, hiding far beyond Neptune. For centuries, we believed the solar system ended with Pluto. But some scientists are now convinced there's another world out there, tugging silently on the orbits of known planets. And they call it Planet X. But how do we find a planet we can't even see? Let's take a step back to understand how humans first discovered planets. Ancient astronomers, without telescopes, mapped the night sky by watching the stars move night after night. They noticed some objects didn't behave like stars. These wanderers, the original planets, moved across the backdrop of fixed stars. Using just observation, ancient Babylonians identified Mercury, Venus, Mars, Jupiter, and Saturn. But Uranus? That one had to wait until 1781. It was discovered by accident by William Herschel, who initially mistook it for a comet using a handmade telescope. Only after watching its path did astronomers realize it was orbiting the sun. Not like a comet, but like a planet. That changed everything. Then came Neptune. Its discovery wasn't accidental, it was predicted using math. Astronomers noticed Uranus wasn't moving exactly as expected. Its orbit was being pulled by something unseen. In 1846, French mathematician Urbain Le Verrier calculated where this mystery planet should be. When astronomers looked, they found Neptune within a single degree of his predictions. This method, using gravitational perturbations, opened a new era. Planets could now be found by the ripples they left behind, even if they were invisible. Which brings us back to Planet X. In recent decades, astronomers have studied the orbits of icy objects in the Kuiper Belt, a region beyond Neptune filled with frozen debris and dwarf planets. Some of these objects have oddly tilted or elongated orbits, as if being pulled by something massive and far away. In 2016, researchers Konstantin Batygin and Mike Brown published a paper suggesting that a planet 5 to 10 times Earth's mass could explain these anomalies. They even estimated its orbital path, an elongated ellipse that takes 20,000 years to circle the Sun. They believe the probability of this being coincidence is just 0.4%. In other words, they claim Planet X's existence is 99.6% likely. Skeptics argue it could be a statistical illusion, a fluke in our data. Or maybe the Kuiper Belt just has more variety than we thought. But the evidence keeps growing. New surveys are being conducted with massive sky-scanning telescopes like Vera C. Rubin Observatory, which will soon provide unprecedented data. If Planet X exists, this is how we'll find it. Not by seeing it directly, but by tracking its invisible fingerprints across the solar system. Some even suggest Planet X might not be a planet at all, but a primordial black hole the size of a bowling ball, but with Earth-like mass. That's speculative, but not impossible. What's clear is this. Just as Neptune was revealed through math, Planet X might be the next planet discovered through pattern, deduction, and persistence. At infinity beyond, we believe the unknown corners of our solar system may hold surprises we can't yet imagine. And one day soon, a blurry dot in a telescope could rewrite everything we know about our cosmic neighborhood.